Hello. An efficient and modern closed-loop system is supposed to adjust itself to the physiology of the patient. We want to show you the behavior of DiBloop DBLG1 system that features both automatic and manual adjustment. First of all, here is the manual adjustment. DBLG1 is a modular system that can be customized. The initiation is simple with only 4 parameters that are required. With DBLG1, you can settle the aggressiveness of the algorithm, the threshold for hypoglycemia, but we will talk here about the glucose target. We have looked at the impact of a modification in the glucose target in the cohort of several thousand of patients that have been equipped last year in Germany. Here are the methods used in this report that required at least 14 days of data before and after a change in the settings of the glucose target. By default, glucose target is set at 110 mg per deciliter and can be customized from 100 to 130 mg per deciliter. Here is the distribution of changes in glucose target in our study. Briefly, here is the impact of changing the glucose target on time in range and on time below range. And here is now the impact of the change of glucose target on sensor glucose and on the coefficient of variation. And finally, the impact on the insulin consumption. So to summarize, the glucose target decrease and increase have a symmetrical impact on all these indicators. You can see on this table that decreasing or increasing the glucose target has indeed a logical and expected impact on all glucose metrics, and this impact can be clinically meaningful and useful.
Hi, my name is Yousra. I'm algorithm team leader within DiBloop, and I will share with you an overview of what's done by the algorithm in terms of automatic customization at patient level. You have here a high-level summary of how the DBLG1 algorithm operates each 5 minutes. I won't have enough time to go in details. The objective here is to show you how the auto-learning impact all the other modules to integrate learning done at patient level. We currently have 2 patents on this auto-learning module. I'm going now in detail on one example, which is impacting the meal management and how it's optimized from one week to another, so you better understand the global functioning of auto-learning that could be done on different parameters. So let's assume we are in week N and need to calculate the meal ratio for the next week. What we will do is using a combination between the last calculated meal ratio N that has been applied during the week N and an ideal meal ratio that could be calculated for this last observed week. The alpha here is what we usually call the learning rate, and more this alpha is high, more the learning speed would be important and will give more weight to very recent observed data. Case. This alpha is calibrated through simulations. Finally, there are several securities. The maximum variation is plus minus 20% from one iteration to another, the 3 first weeks, and plus minus 10% for weeks after when treatment is more stabilized. The third important one is the maximum variation in comparison to the initial meal ratio plus minus 50%. You have here the result of the meal ratio learning on few hundred patients that have an average blood glucose level higher than 180 mg per deciliter the first week. The only change we have from one week to another is the optimization of meal ratio, as it has been optimized by the algorithm without any manual parameter change. What we can see here, there's a significant improvement, especially for patients that start with a very high average blood glucose level during meal period, usually linked to a bad initialization. the algorithm gets stabilized after a few weeks. It's also linked to the fact that it can't go further than plus minus 50% in comparison to initial value. Now the meal ratio learning example has been presented. Here's a global overview of how the customization at patient level works. In one side, there's the impact that could have the user on treatment by changing parameters. In the other side, the algorithm is able to impact some same modules with automatic learning done from 1 week to another. There's an additional short-term learning layer that is applied to normal and hyper management module in order to better include short-term changes on insulin sensitivity factor linked, for example, to hormonal or cartridge change effect. Here are the main three take-home message. First, the customization could be done by doctor and patient manually. When there's no parameter change, the algorithm optimizes automatically at patient level. Second, this automatic optimization helps to achieve international guideline standard. Third, the primary objective of automated optimization is to improve patient treatment with inappropriate initialization. Please do not hesitate if you have any question.